In this video, I will show you how to solve a system of conic sections. For example, the top equation is a parabola. I know that because only one variable is squared, so it's a parabola. Sometimes we have ellipses or circles or hyperbolas. The bottom equation is just a line. So we have a parabola, all right, which I also know is going to be sideways because the y is squared. And we have a line. And we're looking for the points of intersection between them. Whenever we solve a system, our two main tools are substitution and elimination. So for this problem, I'm going to choose substitution. Because I have this small equation, it's very easy for me to get one of the variables by itself, so substitution is a good choice. Whenever I do substitution, I like to write the problem side by side, so I'm going to do that now. So now I've written them side by side. If I subtract x from both sides, I will have y equals negative x plus 3. Now I can do my substitution. Since y equals negative x plus 3, I can take negative x plus 3 and substitute it for y in the other equation. But it won't just be there, it'll also be here. Okay, both of these y's need to be replaced. So then I'm going to have 4 times negative x plus 3 squared plus 3x plus 11 times negative x plus 3 minus 69 is equal to 0. So I cannot distribute this 4. What I need to do is write this twice. Negative x plus 3 times negative x plus 3. I can distribute this 11 though, so I'm going to have 3x minus 11x plus 33 minus 69 is equal to 0. Okay, if I multiply these binomials together, I will get a trinomial. So we're foiling this, or double distributing, whatever you want to call it. I have negative 3x inside and negative 3x outside, so that'll be negative 6x in the middle, and then plus 9. So there's my trinomial. These are like terms, so that's going to give me negative 8x. These are like terms, so that's going to give me negative 36 is equal to 0. Now I can distribute the 4, so I have 4x squared minus 24x plus 36 minus 8x minus 36. I said because I'm noticing that the plus 36 and the minus 36 will definitely cancel each other out. So I have 4x squared, and these are like terms, so this is going to make negative 32x is equal to 0. Both of these are divisible by 4, so my life will be easier if I go ahead and divide everything by 4 now. So that's going to leave me with x squared minus 8x is equal to 0. Now I'm going to factor this by taking out the greatest common factor, which is x. So that's x times x minus 8 equals 0. I can get solutions by setting each factor equal to 0, so that means x equals 0. Okay, because of this, and then x minus 8 equals 0. Adding 8 to both sides gives me x equals 8. So I have these two x values now, 0 and 8. Keep that in your brain. So I'm going to build my solution set up here. but so far I have these x values. I have 0 and I have 8. So these are x values, so that's 0 comma something and 8 comma something. I still need the y values to go with these x values. And I will use this equation to find the y values. So I will substitute my x values in here one at a time. So first I will let x equal 0. All right, that's my first x value. So this equation will become y equals -0 plus 3. So that's just y equals 3. So that gives me my first solution, 0, 3. All right, my computer's slowing down because of all this ink. I might have to stop switching colors. Even though it helps me organize my work, the computer can't handle it very well. Okay, so now we're going to let x equal 8. So this equation will become y equals -8 plus 3. So y is equal to -5. Okay, so this should be my final answer. Let's take a quick look at Desmos.com to see how this line intersects with this parabola at these 2 points. So take a look. Here's our parabola, and here's the line passing through it. And sure enough, they intersect here at 0, 3 and 8, -5, which are the exact values that we found when we did this by hand. That is pretty cool. Looking at number 9, what kind of shapes are these? The first equation is a hyperbola. I know that because the x squared and the y squared have different signs. One's positive, one's negative. Anytime that happens, it's a hyperbola. Now, the second equation is an ellipse. Okay, the x squared and the y squared both have the same sign. They're both positive. If these numbers were the same, like 2 and 2, it would be a circle. But because they are different, 2 and 1, it's an ellipse. So we're looking at an ellipse and a hyperbola. Okay, kind of looks like a janky basketball. But anyway, we're looking for the intersection points between them. So our 2 main tools are substitution and elimination. Looking at all these many terms, I'm really thinking that elimination is going to be our best bet. I can't see an easy way of doing substitution that wouldn't be a mess. So let's do elimination. So imagine that I took this equation and I multiplied it by... Actually, I changed my mind. I don't need to multiply by anything because I see that I've got negative y squared and positive y squared, and I have negative 12y and positive 12y. These are already opposites that are going to cancel out. So I'm going to just work with this, y'all. So I can just go straight to combining like terms. If I combine here, that's going to be 3x squared. These cancel out. Now 11x and 22x, that's going to be 33x. These cancel out. 25 minus 55 is 30. So I have this. Now I'm noticing that all of these are divisible by 3. So we should do that. Make the numbers smaller and easier to deal with. So divide everything by 3. That's legal. So that's going to give me x squared plus 11x minus 10 is equal to 0. This is looking factorable. I've got x and x. Looking at the 11, I'm going to go with 1 times 10. If I want a positive 11, oh wait, this should have been a positive 30. I was about to say, this is looking bad all of a sudden, but this should have been a positive 30. That was a mistake. So that's a positive 10. So now, if everything is positive, I will get the 11. So setting these equal to 0, I will be able to find the solutions. So subtracting 1 from both sides, I have x equals negative 1. Subtracting 10 from both sides, I have x equals negative 10. Now, let me begin my solution set. So these are both x values. So what I have right now is negative 1 comma something. All right, that's my x value. I have negative 10 comma something. I need the y values that go with these x values. So the way that I will get a y value is by substituting these x values back into one of the original equations. Okay, you know what? I feel like I might need this space. Okay, I might have to move this. How much space do I have? Alright, I have room. I'll make it work. So let's let x equal negative 1. We'll start with that. Let x equal negative 1. I'm going to use the first equation. So if x is negative 1, I have negative 1 squared minus y squared plus 11 times negative 1 minus 12y minus 25 is equal to 0. So this is positive 1 minus y squared minus 11 minus 12y minus 25 is equal to 0. Okay, so this is negative y squared. These are like terms right here. In fact, really all three of these are like terms. So I'm going to have negative y squared, and then I'm bringing down the negative 12y next. So 1 minus 11 is negative 10. Negative 10 minus 25 is negative 35. So this is what I get if I combine these like terms. I don't like the fact that my leading coefficient is negative. So what I'm going to do is I'm going to divide everything by negative 1. That will give me y squared plus 12y plus 35 is equal to 0. Now hopefully this is factorable. Otherwise I will have to do the quadratic formula. So this will be, okay, some factoring. So I'm going to have y 35. I'm thinking 5 times 7. If I let both of these be positive, then that will give me 12. 5y, 7y, that's 12y. So I factored it. Now I need to take both of these and set them equal to 0 to solve it. Subtracting 5 from both sides, I get y equals negative 5. Subtracting 7 from both sides, I get y equals negative 7. Now, keep in mind that I got both of these y values from the same x value, negative 1. Okay? I only have negative 1 written here once. So how will I record two y values? Well, the answer is I need to write the negative 1 twice, so I can pair it with the two different y values. So I had to write the negative 1 twice so that I can now pair negative 1 with negative 5 and negative 7. So negative 1 comma negative 5 and negative 1 comma negative 7. These are two solutions so far. Now let's do the same thing with the other x value. Let's do the same thing with negative 10. So let x equal negative 10. And let's see what happens. So if x equals negative 10, okay, I'm going to have negative 10 squared minus y squared plus 11. I'm sort of looking at this and I'm just, instead of negative 1, I'm putting negative 10. So you can follow along by watching me recopy this. So 11 times negative 10 minus 12y minus 25 is equal to 0. Okay, so this will be 100 minus y squared minus 110 minus 12y minus 25 is equal to 0. All right, so now I will have negative y squared. 100 minus 110 is negative 10. And I'm just going to bring down the rest of it for a minute. Now, negative 10 and negative 25 is negative 35. So I will have negative y squared minus 12y minus 35 is equal to 0. Okay? Now, look at this step in the last problem. Do you see that it's the exact same thing? I have negative y squared minus 12y minus 35 equals 0. That's the exact same thing I have now. So obviously the rest of this problem is going to be identical. I'm going to get the same answers. So I'm going to get y equals negative 5 again. And I'm going to get y equals negative 7 again. Okay, I can skip these steps now. Okay, so I'm going to have to do the same thing with negative 10 that I did with negative 1. I'm going to have to write it twice. So I'm going to have, okay, so we got negative 5 and negative 7 again. So these are the 4 intersection points between the ellipse and the hyperbola. Let's take a quick glance at Desmos.com and let's look at the graphs of these two equations and see how they intersect at these 4 points. All right, so take a look. Here's the ellipse in blue, and you can see the hyperbola in red. And we can see that there are 4 intersection points at negative 10 comma negative 7, negative 10 comma negative 5, and then negative 1 comma negative 5, and negative 1 comma negative 7. Exactly the points that we predicted when we worked it out by hand. That is pretty cool. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.